So yes, then we are at the last sprint. So what I've done here is, this is the result we got end of last lecture. Exact same formula, and then for the next term, the only difference here is that it's supposed to be a y down here. So then we have 2 of 5 of these. Next, we'll do the stresses, and that's basically the last thing we need. But it's also going to be a lot of equations. So what we want to solve now is the element. So again, omega e x. So as you can see, we are skipping some details here, but it should be evident what we're doing. We're just using the same tricks over and over again, basically. So now we're looking at this. Similar, we have expressed this using basis functions in our Galeckin projection. This one, sigma x I j t c I j x, and then KL of x dx. This is what we want to solve. So here we also need the chain rule. See. Yep. So for the chain rule, and for this, we get that this partial dx is 1, dx is 1. 2 dx 2. This can basically just be inserted in place of this. So do it this way, and we do the transformation, which yields us, again, sorry, yeah, this is also a double sum. I've just been lazy, so apologies. I, j, 1. Now we're in the big lambda domain. And x, I, j, I, j. Then we're inserting this chain rule. Because we are also changing the coordinates, then we also need to make sure that the derivatives stays the same and respectively. dx 2 dx 2. So T L lambda. Then again, we introduce the same basis functions, these Lagrange polynomials, and we get a big expression. I, j, big lambda. Let's see if we can get this correct. X, I, j, L, I, C, X, I, 1, L, j, X, I, 2, D, X, I, 1, okay, 1 L L 2 D 1 dx. Well, so that's the first term. And we also need to do the second one, which is similar. J. X I J I J K 1 D 2 L L side 2 D side 2 X J and these two look fairly similar, only that have these two differences. So where you apply the derivative. But this we can solve. This we can solve. Again, GLL quadrature, and well, we just have to do it. Yeah. Well, we are here right now. And we have 4 sums. Oops. I, J, M, and N. Because now we're also doing the integral, so now we're trying to solve this by GLL quadrature, and we get x I j I 1 j 2 m I guess by now you see the pattern L and 2 D psi n like so. And then we need to add the term down there as well. I, J, M, N. We've soon used the whole alphabet. Of course, I forgot the lights. So yeah, of course you have to weigh the integrals. So they are going somewhere around there. N, X, I, J, and then we have this whole thing again, L, I, 1 L J psi 2 N L K psi I M D psi 2 L L psi N 2 2 D psi 2 dx J and so. Yep. It's just basically a bunch of bases. And then there's one more equation. So here we still have one sum left because of the derivatives. So we would have to do something extra. So we W and W L X X L T 1 L K 1 X L. So as you can see, this is a more complex. Well, you need more terms for the stresses than you do for the displacements to use. N equals 1, again equals 1, W K W N X K N of T say 2 L L psi 2 L T psi 2 dx psi and then we should be able to solve all of the integrals. So we can use what we've done for the xx to solve the yy, and we can use this again to solve the xy stress. And the problem here is while keeping track of everything. As you can see, there's a very many things to count. So over here we have 4 different basis functions that needs to be directed, but we are left with only 2 different sums of them with the stresses. So a colleague of mine has actually gone through the hard work and implementing this It's still a work in progress, but I can show you the results thus far. Hopefully this will work. Good. So let's see. Example 1. Yes. So in the first example here, you have a regular mesh like this. So this is basically just solving. Here you could do the final difference for this mesh. So this is just a test example, and you can see the traces. He's plotted here. Let's see. This is as graph and the traces. ESD, yes. I guess you are used to seeing this transposed, so then you will have the signal in each of the receivers here, and also in black and white. So this is really an interesting example. The more interesting bit is that you can actually use whichever grid you want. So let's see, this is ES mesh dot mesh, if I remember correctly. Yes. So here's a more interesting example of a mesh. This means that, say you are trying to simulate a hillside, then you don't want to calculate the stuff over here. So then you can have an irregular mesh. But you can also notice that each of these grid cells, they are a trapezoid. So in this method, the spectral elements method, you can't have arbitrary shapes. You can't have like polygons. You can't have triangles, stuff. But still, you can make pretty interesting shapes with this method when it's properly implemented. So this is still a work in progress. So if this was interesting, I would suggest you take contact with Belga so we can actually develop this further. Because Espen quit, unfortunately. Got a better offer at Aker. That is actually everything I have for this course. I assume you want a repetition lecture closest to the exam. So first week of December, would that work? I'll send out an email. We can take this on Blackboard. I've also sent out an email to the Doodle thing for a reference grouping game. I've only gotten one reply, and he could only do it on Wednesday, so I'll have to extend the Doodle. But if you have any feedback, just send me an email or go to the reference members and just ask them if you want to be anonymous. I don't take harshly to critics. Other than that, the exam is the 16th of December. I will unfortunately not be available, but a colleague of mine will take the rounds and help you in the exam. So, yes, if you have any questions for this, sure.
Not now, I mean for example.
Yeah.
Can we have some thinking or?
Yeah, I was thinking a lecture maybe first Tuesday of December.
No, I mean exams now in December, isn't it? When we can take this meeting, we have to prepare before exam.
Mm.
So some question came right before exam, 1 to 3 days, I think so.
I can't do that because I'm in the US then. I'm holding a presentation. so I can't do it.
1 week, because we have 2nd and 4th December 2 exams, and
Mm.
the 16 your course. So if we have 1 week, for example,
Mm.
I think
Yeah, I'm gone the 8th of December.
in December.
Yes, 8th till the 16th of December. Then I'm on a conference, so I can't.
Before 8 and after 4.
Yeah, after 4.
After 4th, okay? Which date is the 4th?
7.
It is a Monday.
So the 5th then,
5th.
Yeah. And regular lecture hours. Would that work?
Yeah.
Good, then we say the 5th. Mm. And yeah, I won't prepare anything special, so you would have to ask questions.
You send in questions on
Yes, you could. That's why we have Blackboard. Or just email as well. So yes, hope you've learned something at least during this course, and thank you. You're free until the exam. Thank you.